Assalamu alaikum students. Today we start exercise 1.3 about limit. Question 1 is very easy. In this question we directly put the limit, but in question number 2 we first simplify the expressions and then put the limit. Here in first question, if we directly put -1, it becomes undefined infinity, so we reduce and factorize. From the numerator we common x square, and in denominator we factorize a square minus b square is equal to a minus b and a plus b. Then we put the values and we get the result. And in next part we rationalize, and in numerator it becomes a square minus b square. Then we have the answer, and in next part is similarly like the previous question, rationalize it and get the result. In this part we use the formula we prove in the examples, which is equal to x raised to power n minus a raised to power n over x minus a is equal to n a n minus 1. We divide numerator and denominator by x minus a, and now the numerator and denominator are same like this formula, so we apply the result. Because the numerator and denominator have same power, we subtract these powers. This is the last form and also answer of this question. In question number 3 we use the formula limit theta tends to 0 sin theta over theta is equal to 1. Here we have sin 7x, we multiply and divide by 7. Now this is in the form of theorem sin 7x over 7x, so therefore it is equal to 1. In second part it is x degree, we convert it in radian by multiplying pi by 180, and by the same number we multiply and divide, and it is equal to 1. This is the proof of x raised to power n minus a raised to power n over x minus a. Second case, when we let n is a negative integer, x raised to power minus m and a raised to power minus m is equal to 1 over x raised to power m minus 1 over a raised to power m. Then we LCM. When we take LCM right in the denominator, and above values a minus x, we take minus common from numerator, it becomes x minus a, and apply limit, and the value in fraction it is equal to the formula of case 1. We apply the result m minus 1, and then the same base we subtract the denominator values from the numerator, m minus 1 minus m So because minus m is equal to n, therefore it is also equal to n a n minus 1. So in this question, 1 minus cos theta over sin theta, we rationalize these values. 1 minus cos, 1 plus cos, it is equal to 1 minus cos square. 1 minus cos square is equal to sin square. And then apply the limit. Sin 0 is equal to 0 and cos 0 is equal to 1. And in this question, we put value of sin square 1 minus cos square, and then simplify and get the result. In this question, sin x over pi minus x, sin x is also equal to sin pi minus x. As we say, sin theta is equal to sin 180 minus theta, because sin not change on the value of 180 and 360. Therefore we can write sin x is equal to sin pi minus x. Now here angle and denominator are same, so therefore it is equal to 1. Now in this question, sin ax over sin bx, we multiply divide numerator by ax and denominator by bx. Both are equal to 1, x cut by x, and it is equal to a over b. X over tan x, we write tan x is equal to sin over cos. So x over sin into cos x. X over sin is equal to 1, cos 0 is equal to 1. 1 minus cos 2x over x square, we write 1 minus cos 2x is equal to 2 sin square x, because sin square x is equal to 1 minus cos 2x over 2, and sin square over x square is equal to 1. 2 into 1 is equal to 2. Now in this question we have sin square theta over theta. We multiply divide by theta. Now it is sin square over theta square, it is equal to 1, and we apply limit theta tends to 0, so it becomes 0. Secant x minus cos x over x, we write secant is 1 over cos x. Taking LCM, 1 minus cos square over cos, the LCM move to the denominator. And 1 minus cos square is equal to sin square. Then we write in fraction sin x over x and sin over cos. Sin x over x is equal to 1, and on the other fraction we apply limit sin 0 over cos 0. Sin 0 is equal to 0 and cos 0 is equal to 1. 1 minus cos p theta over 1 minus cos q theta. Here this is equal to the formula 2 sin square p theta over 2, because if we have sin square x, then it is equal to 1 minus cos 2x. If we half the angle, then it is equal to 1 minus cos x. Numerator is equal to 2 sin square p theta over 2, and denominator is equal to 2 sin square q theta by 2. Now we multiply divide by p theta by 2, numerator and denominator, and we write whole square, and sin p theta over 2 over p theta over 2 is equal to 1, and so therefore it is equal to p square over q square. In this question, tan minus sine theta over sine cube theta, we write tan is equal to sine over cos, then taking LCM, next we common sine theta from the numerator, and sine square is equal to 1 minus cos square, and 1 minus cos square is equal to 1 minus cos and 1 plus cos. Then we apply limit and it is equal to 1 over 2. Now here we prove sine theta over theta is equal to 1. Now we first draw the diagram. Here a line AD tangent to the circle at point A. Center of a circle is O, and it is a unit circle of radius 1, and AOB is a angle, acute angle triangle with theta in radian. Then we draw BC perpendicular on OA, join AB, and then we draw OB to the tangent T, intersect the tangent at point D. Now from diagram we have these points, and greater triangle is AOD, and then sector, and then triangle inside the circle. Area of triangle is equal to 1 over 2 height multiplied by base. Area of sector is equal to 1 over 2 r square theta, and area of triangle again height multiplied by base. In first triangle, height is AD and base is OA. In second sector, radius is equal to 1. In third, perpendicular height is BC and base is OA. Because radius is equal to 1, and in triangle AOD, tan theta is equal to perpendicular of base, therefore AD is equal to tan theta. And in triangle COB, sin theta is equal to perpendicular of hypotenuse, and OB is equal to radius, therefore BC is equal to sin theta. We put these values in above equation, and then we multiply by 2, and then we divide by sin theta. Now this is equal to 1 over cos theta over sine and 1. Then taking reciprocal, when we take reciprocal, the inequality sign change. Limit theta tends to 0, cos 0 is 1, therefore limit theta tends to 0, sin theta over theta is also equal to 1. And in this question we apply the rule 1 plus 1 over n with the power n is equal to e when limit n tends to infinity. The simple way to understand is that the value inside the bracket and the power is reciprocal of this value, then it is equal to e. Here we have 1 over n, and we change the power is equal to n, and it is equal to e. And in this question we change in power like 1 plus 1 over n with the power n, and we move 1 over 2 to the second side, and it is equal to e raised to power 1 by 2. and here we have negative sign. If we have negative inside the bracket, we mark negative in the power and balance with the -1, and it is equal to minus e raised to power -1, or we can write 1 over e. Next again 1 over 2n, we multiply divided by 2, therefore e raised to power 1 by 2. Now we have 4 over n, we multiply divide by 4 in power, and it is equal to e raised to power 4. Now this is the proof of the theorem. We use binomial theorem. 1 plus x raised to power n is equal to 1 plus nx plus n minus 1 x square n minus 1 n minus 2 over 3 factorial is equal to x cube. We put x by 1 over n. In all x we replace it by 1 over n, because when we compare the formula 1 plus x raised to power n and the proof, and in place of x we have 1 over n, so we put x raised to power x is equal to 1 over n. In the second term n cut by n. In third term we change their place n over n and n minus 1 over n, and in fourth term we also arrange like that, and then we simplify in bracket. Now we have this form, and then apply limit. Limit is n tends to infinity. When we put infinity in denominator is equal to 0. Here we put the limit, it is equal to 0, and when we sum these values, this is equal to 2.718, which is the constant value of E. So this is the proof. Now here again questions. We have 1 plus 3x, and we make in power 1 over 3x. We move to outside and multiply 3 and divide by 3, and it becomes e raised to power 6. In this 1 over 2x square we multiply by 2. Now here we have a negative value, we multiply divide by -2, and in this question we reciprocal the whole term and the power become negative, and then we separate the denominator value. X over x is equal to 1. So in bracket is positive sign, we move negative to the outer bracket, and it becomes e raised to power -1. Now in this question we have e raised to power 1 over x minus 1, e raised to power 1 over x plus 1, where x is less than 0. X is less than 0 means x is negative. We replace x by negative value. Because the power is negative, we make it positive by taking reciprocal of this value. Then we apply limit, and 1 over 0 is infinity. Therefore any number with power infinity, it is also equal to infinity, and 1 over infinity is equal to 0. So we have the answer is -1. Again the same question, but here we have x is greater than 0. Now we directly common e raised to power 1 over x, and in first term we common e raised to power 1 over x. In second term we have no value, so we divide it by 1 over e raised to power 1 over x, and then we apply limit. Here the method how we common this value. If we common a, we place a by 1, and in second term we have no a, so we divide it by a. Then we apply limit in the term 1 over 0 is equal to infinity, e raised to power infinity is equal to infinity, and 1 over infinity is equal to 0. So we have the answer is 1. Okay student, try to solve these questions. If you have any problem, then send it to me. Jazakallah. Allah Hafiz.